Hey guys, so we're continuing on our lessons about how to work with rational numbers. Yesterday we went through how to add and subtract with different types of rational numbers. Today we will be doing multiplying and dividing with different types of rational numbers. Okay, so we'll start with doing whole numbers and decimals. We'll do both a multiplication and a division example. So the first example we'll do is 10.2 times negative 30. So we're going to set this up so that we can do long multiplication. So we start here, and we're going to multiply straight up and then to each of the numbers in the top row. So 0 times 2 is 0, 0 times 0 is 0, and 0 times 1 is 0. Then we go down and put a 0. And then we go over to the second number on the bottom row, and it is going to get multiplied by everything in the top row. So 3 times 2 is 6. 3 times 0 is 0, and 3 times 1 is 3. Then we add, so 0 plus 0 is 0, 0 plus 6 is 6, 0 plus 0 is 0, and then 3. And then our last step, well, actually we have 2 more steps. Next, we figure out whether this is going to be a positive or negative number. Because we had a positive number multiplied by a negative number, our answer is negative. If you have 2 positive numbers, your answer is positive. If you have 2 negative numbers, your answer is positive. But if you have one of each, your answer is negative. And then the very last thing to do is figure out how many decimal places we should have. And all we do is we look at both of the numbers up top and see how many numbers they have behind the decimal place. And we only have one number, this 2, behind a decimal, which means we only need one of these to be behind a decimal. So our final answer would be negative 306.0. Okay, for example 2, we will do long division. So negative 9 divided by 0.2. The way we would set this up, our negative 9 goes under our division sign. The 0.2 goes in front of our division sign. And then all we're going to do is we're going to ignore the fact that this decimal is here for now and just say how many times does 0.2 go into negative 9? And it goes in 4 times. 2 times 4 is 8. But I need this to be a negative number because that is a negative number. So I'll put a negative sign there. Now 2 times negative 4 is negative 8. So now they're nice and close. If we subtract them, you'll figure out that you're off by 1. Okay. Now again, don't actually subtract them with the negatives, just ignore the negative signs for now. And you could even ignore this one up here if you wanted and just put the negative sign in at the end. So you can do that as well. If that's easier for you, again, just ignore that negative sign for now, ignore these negative signs. Do 9 minus 8 is 1 remainder. Then we're going to put in a 0.0, which means we also need to put a decimal place in there. And that allows us to bring down this 0. Now we say how many times does 2 go into 10? Well, it goes in 5 times. 2 times 5 is 10. We subtract those, we have 0 remaining. Okay. And then this is where you could put that negative in if you wanted to just leave it to the end. You would just say, okay, if we go back to our original equation here, We had a negative number divided by a positive number. Just like with multiplication, if one of your numbers is negative and one is positive, your answer will be negative. If they're both positive or both negative, your answer will be positive. It's only when you have one of each that your answer is negative, like our answer is here. Now, this actually isn't the final answer in this case because we started off by ignoring the fact that that was a 0.2 and not a 2. So because we had 0.2 and yet we were pretending it was an actual 2, what we essentially did was we moved this decimal spot, that decimal one place over, which means we have to do the same thing with this decimal up here that was in our answer. So we're going to take it and move it one spot over, since that's what we did to the 0.2 to really get it to pretend to be 2. And so our actual final answer is negative 45. Okay, with fractions, it's actually probably even easier than that. And it's definitely easier to multiply and divide fractions than it is to add and subtract them. And the reason for that is that you do not need a common denominator when multiplying and dividing fractions, only when you're adding and subtracting them. If you're multiplying fractions, you just multiply straight across the top and straight across the bottom. And then at the end, don't forget to put it in lowest terms if possible. If you're dividing fractions, you keep, change, flip. Keep the first fraction, change the division sign to a multiplication sign, and then flip the second fraction upside down. And then you multiply straight across the top and straight across the bottom. Put your final answer in lowest terms if possible. So the next example will be fraction multiplication. So 3/5 times negative 2/3. Again, we just multiply straight across the top and straight across the bottom. Actually, I'm going to make this, yeah, no, that's fine. So 3 times negative 2 is negative 6. 5 times 3 is 15. And then negative 6 and 15 are both divisible by 3. So in lowest terms, it's negative 2/5. For example 4, we will do negative 4/7 divided by negative 1/2. So again, we're going to keep our first fraction, change our sign, and flip our second fraction. So 2 over negative 1. Then we multiply straight across the top. So negative 4 times 2 is negative 8. 7 times negative 1 is negative 7. Now this time, 8 and 7 aren't both divisible by anything that could simplify this, but one thing you do have to do to simplify this is know that if you have two negative signs, one on the top and one on the bottom, they actually cancel out. So what we end up with is just 8 over 7 as our final answer. Okay? Okay, the last type that we're going to look at here is how to multiply and divide with mixed numbers. And the easiest way to do that is to just convert into fractions, multiply or divide the way we just went through, and then if possible, convert back to a mixed number. So for our multiplication example, let's do 2 1/3 times 3 4/5. So we're going to convert these into fractions by multiplying and then adding. So 3 times 2 is 6 plus 1 is 7, and we keep the denominator, so 7 over 3. And then 5 times 3 plus 4 is 19. Keep the base. And then we just multiply straight across the top. So 7 times 19 is 133. And then 3 times 5 is 15. And then, of course, put it back into a mixed number. So we're going to do how many times does 15 go into 133? And to figure that out, we just do 133 divided by 15. You'll get 8.87-ish. But we're just going to keep that whole number in front. So just the 8 that's in front of the decimal there. And then to figure out how much is left over, I'm going to do 15 times 8. That gets me 120. So I'll just do 133 minus 120. So that is 13 left over, and we keep our base. Okay. So again, the way I solved that is I did 133 divided by 15 is 8.7-ish, but I just keep the 8. Then I did 15 times 8 is 120. And then I did 133 minus 120 is the 13, which I used here. Okay. And then the 13 over 15 cannot be put in any lower terms than that. So that's my final answer. For the division, let's do 4 1/3 divided by 2 1/2. Again, I'm going to turn these into mixed numbers. So 3 times 4 is 12, plus 1 is 13, and we keep our denominator. 2 times 2 is 4, plus 1 is 5 over 2, so 5/2. Then we do keep, change, flip. Then we multiply straight across the top. So 13 times 2 is 26. And 3 times 5 is 15. And then our last step, 15 goes into 26 once. 15 times 1 is 15. And 26 minus 15 is 11. So there's 11 left over after I take 15 out of 26. And then I keep my base. And once again, that is in lowest terms. So that's your final answer. Okay, that's all for today's work. Let me know if you have any questions.